Our first question asks to use the Pythagorean theorem to find the distance between points A and B. So first step, we'd be given 2 points and you'd have to make the right triangle. Then just count the spaces. So this side length would be a length of 2. This one would be a length of 4. And then we use our a squared plus b squared equal to c squared, where c is my hypotenuse. Other two sides don't matter where you put them in. So you've got 20 after you square everything. Square rooting, you arrive at the square root of 20. And since they use the variable d, I should use the variable d. Math studies, we don't care if you simplify things or not, so you can leave it as such. What you might not have realized is that the Pythagorean theorem derives the distance formula. So in this problem, this is actually a different triangle, but to find the side lengths, this would be 6, this would be 2, so this would have 6 minus 2. That's how you'd get this side length. Here you'd have 5 minus 2. This side length would be 3. So that's where this comes in. When you guys subtract the x2 minus x1, you're actually just finding the side length of the triangle. y2 minus y1, you're doing the same thing. And then square rooting it all just comes from the Pythagorean theorem. So there's your formula. So our first question asks us to classify a triangle as equilateral, isosceles, or scalene, and we're given 3 points at the top. So I've got some triangle ABC, don't know, I'm just drawing a rough sketch, and I need to determine this. So I would find all your side lengths just by using the distance formula. I just go from one x to another x, or one y to another y, doesn't matter which one you go to, and make sure that you go the same direction when you do your x's. So I can subtract the x's, 5 minus 2 squared. Subtract the y's, 1 minus negative 1 squared. And then I've got to simplify. So I've got 3 squared plus 2 squared. So AB should be 9 plus 4, should be the square root of 13. Here are the next two side lengths. Just make sure you go in the right order. 5 minus 0, 1 minus 2. You should always get positive lengths for distance, so if you end up with a negative, you made a mistake. Next one, 2 minus 0, negative 1 minus 2. So here I've got square root of 13, square root of 13, and this one's different. So I've got two sides the same, that'll be an isosceles. The next question asks if it has a right angle or not. Something that you guys might have forgotten that you can use is Pythagorean theorem. Pythagorean theorem will work if you have a right angled triangle. So C has to be the square root of 26 because C that would be the biggest number. That has to be your hypotenuse. And then the other two are just the square root of 13. And then you just have to see if it's true or not. So square root of 13 squared, that just undoes itself. Same thing here. Same thing here. So I'd have 26 equal to 26. So yep, it would work, and you'd have our right triangle. In example 2, I'm given distance, square root of 10 units apart, and I've given 2 points. So I can actually just plug into the distance formula. So my distance, my d part, would be the square root of 10. And now I've got x2 minus x1. Again, doesn't matter which way you go. I'm going to go this way. So I've got negative 1 minus negative 2. And I've got q minus 4. Now, each side is under a square root. To undo that, you can actually square both sides. That will undo a square root. They're the opposites of each other. So now I'm just left with 10 over here. I'm going to simplify a little bit in this spot. So I've got 1 squared. Oops, I don't have that anymore. That will go away on the other side. So now I've just got here 1 squared plus q minus 4 squared. Your temptation might be to FOIL this. I'm going to tell you not to do it. There's a nice way to solve it by leaving it as such. Your next step, minus 1, minus 1. So now I'm left with 9 equal to q minus 4 squared. And since I've got a squared here, what I can actually do is square root both sides. Square rooting both sides here. I can have 3, but I can also have negative 3 because negative 3 times negative 3 would give you 9. So I'm going to write it as plus or minus 3. When I square root here, square root and the squared undo each other. And now I've just got q minus 4. So what you just have to be careful at this point, you could have q minus 4 equals positive 3, and you can also have q minus 4 equals negative 3, both solutions. So here q would be 7, here q when you solve it would be 1, and those are your two possible solutions.